Hi tens, I had a request for number 15 on, I believe it's page 188. So a point lies 2 units above the x-axis on the axis of symmetry of a parabola with the equation y equals x plus 4 times x minus 6. So this is the equation of our parabola. Okay, it says how far is it from this point to the point on the curve where x equals 5. So what do we know? Well, we know that we have a parabola, right? And we know that we have a point on the parabola at x equals 5. So why don't we set that up first, and then we can figure out the rest of the problem. So let's go ahead and draw a quick sketch. Okay, so first we know that y is equal to x plus 4 and x minus 6. So we know what our x-intercepts are, right? We know that our first x-intercept, so x-intercept number 1, right, is going to be equal to negative 4. And then we know that x-intercept number 2 is going to be equal to positive 6. So remember that our x-intercepts are when y is 0, so we'd have to rearrange this to solve for x, in which case we'd be subtracting 4 from both sides. And if we rearrange this to solve for x, we'd be adding 6 to both sides. So our x-intercepts are always the opposite of what we expect. So I'm just going to go ahead and put that over here. So negative 4 and 1, 2, 3, 4, 5, 6. So I have 2 points on my parabola, and at this point I don't really know anything else, but I also know that there's a point on the curve at x equals 5. So I can go ahead and find out where that point is. So if x equals 5, then I know that y is going to equal, well, I can replace x with 5, so I have 5 plus 4, and then I can replace x with 5, so I have 5 minus 6. So now I'm going to go ahead and do my math. So brackets first, so I have 9 times, and then when I do 5 minus 6, I get negative 1. So 9 times negative 1 is equal to negative 9. So the point on my curve then, or on my parabola, is going to be 5, negative 9. So I'm going to go ahead and draw that point. So 1, 2, 3, 4, 5, and then it's going to be kind of way down here. Maybe I'll have these go by 2, so negative 2, negative 4, negative 6, negative 8, negative 10, just so I can draw it. And so my point's going to go here. So at this point, I know that the parabola is going to open up, and I don't really know much more about my parabola. So I could go ahead and draw a sketch right now, but it'd be nice if I at least knew where the vertex happened. So I'm going to go ahead and figure out, well, at least, never mind, I'm just going to sketch my parabola. So if I have a point here at negative 9, then I know based on symmetry, right, if this is like 1 away and down at negative 9, then this would be 1 away and down at negative 9. So I have a parabola, and I can kind of draw it and draw it. And then I don't really know the rest of the parabola or what it looks like, but I'm just going to go ahead and kind of sketch it a little bit, because I know that at some point, so it's going to look something like that. Okay, so I have my parabola, and this point here is the one that I'm interested in. This is the point 5, negative 9. So now let's go back and look at the question. Well, the question said that there's a point, and it lies 2 units above the x-axis, so it's going to be 2 units above the x-axis, and it lies on the axis of symmetry. So it's not actually on the parabola, right? It's just telling us that it lies on the axis of symmetry. So I need to figure out where my axis of symmetry is so that I know the x value of the point. But here, right, I know that the y-coordinate of the point is going to be 2, because it's 2 above the x-axis, and I can figure out the axis of symmetry. Okay, so so the axis of symmetry is always halfway between the x-intercepts. So I already know my x-intercepts, which are negative 4 and 6, and to find the halfway point, I just need to add them up and divide by 2. So my axis of symmetry is equal to negative 4 plus 6 divided by 2, and so my axis of symmetry is equal to x equals negative 4 plus 6 is 2 divided by 2, and so x is equal to 1. So remember, when you have an axis of symmetry, it's always defined by an equation. So I'm going to go ahead and draw myself an axis of symmetry. Okay, so I know it's a line because it's an axis and it goes through x equals 1. So I know that this is going to be the symmetry line for the parabola. Okay, and I know that on this line, 2 units above, right, and I had these going up by 2s if you remember, I'm going to plot my point. So this then has to be at 1 and 2. So I have a point here at 1, 2, and I have another point down here at 5, negative 9. And so the question is saying, how far is it from one point to the other? So it wants to know the distance between the 2 points. Okay. So this we can do in one of 2 ways. It depends on whether you've learned it or not, but there's a formula for the distance of a line, okay? And the distance formula is just the square root of the difference between the x values squared plus the difference between the y values squared, okay? And if you don't remember this formula, you can get this formula at any time simply by creating yourself a Pythagorean triangle, or sorry, simply by using the Pythagorean, right, and creating yourself a right angle triangle. So if you figure out the length of this side and you know the length of this side, then you can just square this and square this, and then take the square root. But for now, we'll just use the distance formula as I've outlined it, okay? So all I'm going to do then, okay, is, well, this is, and it doesn't matter, we can call this one x1, y1, and this one x2, y2, okay? So it's really just the first point and the second point. That's all those 2's and 1's represent. So if I take the second point, which is 5, minus the first point, which is 1, then I have 5 minus 1 squared. And now I'm going to do the same thing. So what I'm doing is I'm finding the length of this line, right? 5 minus 1 gives me the length of this line. And then I want to figure out the length of this line. So I'm just going to take my y2, which is negative 9, and I'm going to subtract 2, and then I'm going to square it. So now I'm looking at the length of this line. So I'm just going to keep going. So 5 minus 1 is 4, and negative 9 minus 2 is negative 11, and 4 squared is 16, and negative 11 squared is 121, and then 16 plus 121 is 137. So therefore, the distance between the 2 points is 137, the square root of 137 units. So just to do a quick recap, right? We look at what we know. Well, we know the parabola, we know what the x-intercepts are, we know what an x is, so we can actually figure out what y is at that point and sketch our parabola, okay? We also know that we have a point that lies 2 units above the x-axis, and we know that it lies on the axis of symmetry, so we can figure out our axis of symmetry by just adding up our x-intercepts and dividing by 2. We know that our x then is going to be 1, and that our y is going to be 2. And sorry, I kind of skimmed over this. We can easily find out what the point is when x is 5, okay? Because we can simply plug x equals 5 into our equation when we get 9 and negative 1, and when we multiply them together we get negative 9. So once we have our 2 points, right, we actually didn't it's nice to see it on a diagram, but once we have our 2 points, we're just finding the length of this line, okay? And you can either do it using the Pythagorean theorem, where you create yourself a right angle triangle, and you just do like a squared plus b squared equals c squared, or you can use the distance formula, and the distance formula uses the Pythagorean, and it just gives you a little bit more info, tells you how to calculate the length of each side. So our distance formula is just you take the difference between the x points, and you take the difference between the y points, and then we end up with, so our x's, so if you look here, you'll see that I labeled this x1, y1 and x2, y2. I could have done it the other way around. It really wouldn't have made a difference. You just have to label them, because as soon as you square it, any negatives you have are going to become positive, so it's going to be fine. So again, I took my x's, so 5 and 1, so 5 minus 1, and then I took my y's, negative 9 and 2, and found the difference between them. So I got 5 minus 1 is 4 squared, and negative 9 minus 2 is negative 11 squared, and then I did the math on that, so 4 squared is 16, and negative 11 is 121, and then I ended up with adding them up to get 137. So I know the length of this line is the square root of 137. And I'm not going to put that in my calculator, because that's a more exact answer, right? If you put it in your calculator, you're going to get something that's rounded, and it's going to be a long decimal number. So this is actually a better answer because it's more exact. Anyway, 10s, I hope that helps.